Hello students, this is Shashikil and today we are going to discuss about thermal physics and A2 physics. So the topic that we are going to discuss today is temperature. This is the first topic in the thermal physics, and in this topic the subtopics are thermal equilibrium and then some temperature scales. This is actually the very basic chapter for this section. Okay, about temperature, we know that it's the measure of average kinetic energy of molecules in a substance. So temperature is proportional to average kinetic energy of molecules of the substance. And you know, average kinetic energy means kinetic energy of one of the molecules in the substance. Temperature is also defined as flow of heat energy from a region of higher temperature to a region of lower temperature. And in fact, we say that we can just modify this to another thing, which is heat. Heat is the flow of energy from a region of higher temperature to region of lower temperature. And greater the temperature difference between the two regions, greater would be the flow of heat energy. And the SI unit for the temperature is Kelvin, and the other units are degrees Celsius and Fahrenheit. Okay, well, if we talk about thermal equilibrium, if the two regions between which temperature were different and between which heat energy was shifting, so if both the regions got the same temperature, then there is no heat that flows between them. The state of regions is known as thermal equilibrium. So let's say there are two objects, like this is object A and this is object B. And let's say the object A is at higher temperature. So I'm making it red. So this is object A. So what happened is this is, let's say, at 100 degrees Celsius and this is at 50 degrees Celsius. So what happened is heat energy from this flows to B, of course, when they're in contact with each other. And after a certain time, both of them got the same temperature. Let's say the both temperature become 70 degrees. So 70 degrees, 70 degrees. So there will be no more transfer of heat over there. So that's why we say that these are in thermal equilibrium. If you want to measure the temperature, of course, the temperature as a unit is Kelvin, but you measure in degrees Celsius, and then you use this equation, like adding 273.15 into it, can convert temperature into Kelvin. And the other way, you have to subtract temperature in Kelvin from 273.15 to give back to temperature in degrees Celsius. That's the example. The two bodies are in contact with each other at here. Thermal energy always flows from hot to cold region, and until both the bodies got the same temperature, and we say that these bodies are in thermal equilibrium. Well, now we have to look for some temperature measurements. We know that a thermometer is an instrument that is used to measure temperature. And there are many types of thermometers which use specific physical property of material that varies with the temperature, known as the thermometric property that we use in thermometers. The examples are the density of the liquid, and then the volume of gas at constant pressure, then resistance of metal, and then EMF of thermocouple. Okay, so these are the four properties that we are going to use. So in every case, the thermometer must be calibrated at two or more known temperatures, because we have to, like in all of these, we have to calibrate the thermometer so that we can make a scale on it and we can measure any temperature. So for the calibration purpose, the normal temperatures are 0 degree and 100 degree. 0 degrees the ice point or melting point, or freezing point, and 100 degrees Celsius the boiling point of the water, because these are the common temperature that we know. Okay, now let's look upon the type of thermometers. The first one is the liquid in glass thermometer. As you can see, this is a clinical thermometer. Its range is from 35 degree to 42 degree because human body temperature lies in this range. So a liquid in glass thermometer depends on density change of liquid, like we commonly use mercury or alcohol, like its expansion is used. It consists of a thin glass capillary tube containing a liquid that expands with temperature. Okay, and then a scale along with side of the tube allows the temperature to be measured based on the length by which the mercury expands. The next thing is volume of gas at constant pressure. So this is a volume gas thermometer. Then let's assume that there is a ideal gas over there. And we know that its volume is directly proportional to temperature. And then there is mercury in this column. So let's say if the temperature increases, like if this gas absorbs heat, then of course it expands more. When it expands more, it pushes this mercury down from here, right? And when it pushes the mercury down from here, then from here, the liquid column goes up. So this property is used to measure the temperature. So the volume of ideal gas is directly proportional to temperature. We know that in Charles' law, volume proportional to temperature, greater the temperature, greater would be the volume because gas expands. As the temperature of gas increases, its volume increases. So a gas thermometer must be calibrated by knowing the temperature of gas at certain volume. A temperature scale can determine depending on how quickly the gas expands with temperature. So actually, this is just used to calibrate. This is just used to measure the temperature of certain things. This is not a common thermometer though. Okay, then resistance of the metal. Well, this is a resistance thermometer. There are like, this is the wire having some resistor, and then it is connected to the two terminals, which are going to measure the resistance. So we know that electrical resistance changes with temperature, like resistance proportional to temperature, like the resistance of filament lamp increases when current increases, right? And for metals, resistance increases with temperature increases at steady rate. And for thermistors, the resistance changes rapidly over a narrow range of temperatures, because for resistors, the resistance temperature graph is exponential graph. So as the thermistor gets hotter, its resistance decreases. Like that's the other way with the metals. In metals, as metal become hotter, their temperature, the resistance increases. But in thermistor, as it gets hotter, its resistance decreases. This means that a thermometer based on a thermistor can be used to measure a range of temperatures. The relationship between resistance and temperature is non-linear. This means that graph of temperature against resistance will be a curved line, and then you will calibrate the thermistor. It's like if this is the temperature, this is the resistance. So the thermistor temperature resistance is going to be an exponential curve. Okay, the next one is EMF of a thermocouple. So a thermocouple is an electrical device that can act like a thermometer. It consists of two different wires of different specific heat capacities, and then you connect them together, making two junctions. Like this is metal one, which is connected one end to the voltmeter and other end to this junction, and metal two, the other end is, one end is to the voltmeter and the other end to the wire. So the voltmeter end is placed at known temperature, and the other junction is placed at the spot where you have to measure the temperature. And then the voltmeter will show you some reading, and that reading is known as EMF. So you need to calibrate the voltmeter into temperature if you want to use this. So this thermometer is relatively a quicker thermometer. It's more sensitive, it's more responsive, because you have to measure and you can measure the rapidly changing temperature through it as well. Okay, now about the scale of thermodynamic temperature. You know that we commonly measure the temperature in Celsius because that's easy to calibrate. We know that the melting point of ice is 0 and boiling point is 100. That's why we use Celsius thermometer. Okay, and then the thing is, we can use Fahrenheit as well, and Kelvin as well, but Kelvin is the SI unit. But the thing is, Kelvin is used in thermodynamics, and it is a thermodynamic scale. It means it's hard to construct Kelvin thermometer, but it's easy to construct degree Celsius. So we prefer to measure temperature in degree Celsius, and then we use the equation to convert it into Kelvin scale. So what's the Kelvin scale? Let's look at it. The Kelvin scale is known as the thermodynamic scale, and it was designed to overcome the problem with scales of temperature. The thermodynamic scale is said to be an absolute scale that is not defined in terms of property of any particular substance. This is because the thermodynamic scale Okay, this is because the thermodynamic scale do not depend on property of any particular substance. This is the main thing. Okay, and like the degree Celsius depends on the expansion of the liquid or resistance thermometer. But if you want to make a Kelvin thermometer or absolute scale, there is no physical property that you can use, because in Kelvin, the lower fixed point would be 0 Kelvin, and so far we cannot achieve, any substance cannot achieve 0 Kelvin. So what is absolute zero? Absolute zero, absolutely zero. So on a thermodynamic or Kelvin scale, absolute zero is defined as the lowest temperature possible. So the lowest temperature that is possible to achieve is known as absolute zero. It's actually 0 Kelvin or minus 273.15. And actually it's not possible to go over there. So it's actually the temperature at which the atoms or molecules in the substance have zero kinetic and potential energies. So the matter atoms loses all of their kinetic and potential energies. So at that temperature, like it's 0 Kelvin. So this means at 0 Kelvin, it is not possible to remove any more energy. So even in space, the temperature is roughly 2.7 Kelvin, just above absolute zero. So it's really difficult to get absolute zero temperature. Okay, if you have to use Kelvin scale, what you do is you use these conversion equations from Kelvin to degree Celsius and from degree Celsius to Kelvin. And one important thing is that divisions on both Kelvin and Celsius scales are equal. This means that a temperature change of 1 Kelvin is equal to temperature change of 1 degree Celsius. So that's it for today. And next video, which is the video lecture 2, will be for the comparison of thermometers. So we will compare the thermometers and we will see their advantages and disadvantages. So until then, thank you very much. Take care and we'll see you soon in the next video.